Good morning, students. Sejanandam. I'm Professor Priya Sharma of EC Department, SIRT College, Sage Group, Bhopal. So this is our third video lecture on the series of analog and digital communication lectures. So today we are going to deal with the frequency modulation and phase modulation. Earlier we have discussed about the amplitude modulation, AM modulators and demodulators. Now on third lecture, we'll be continuing with the frequency modulation. So first of all, what is frequency modulation? Let me drag it upwards. Okay, right now. So as we have seen the classification of the modulation, so frequency and phase modulation comes under the angle modulation. So in angle modulation, either the frequency or the phase of the carrier is varied according to the massive signal, but the amplitude of the carrier remains the constant. It has several advantages over AM, such as noise reduction, improved system fidelity, and more efficient use of power. Yes. So coming to the frequency modulation first. Frequency modulation is the process of varying the instantaneous frequency of the carrier signal in proportion with the instantaneous amplitude of the modulating signal. So this is the waveform of the frequency modulation, how it takes place. This is the massive signal or the modulating signal. This is our high frequency sinusoidal carrier wave. Now, after passing it through the modulator, the frequency modulation is seen like this. When it is for maximum positive, the frequency increases, and when it is least, the amplitude of the massive signal is least, its frequency decreases. So this is how you can see over here, the frequency is high. This is the least frequency of the carrier wave, and this is the highest frequency. Note down, the students, that the amplitude and the phase remains the constant. Only the frequency changes. The amount by which the carrier frequency varies from its unmodulated value is called the deviation. Deviation is defined as the maximum the frequency will vary from the modulated wave and is proportional to the instantaneous value of the modulating voltage. The rate at which the frequency variation or oscillation takes place is equal to the modulating frequency, which is denoted by FM. The amplitude of the FM wave almost always remains the constant. Now, what is frequency deviation? Frequency deviation is the maximum departure of the instantaneous frequency of the FM wave from the carrier frequency. And the modulation index of the FM is given as the ratio of the frequency deviation to the modulating frequency. Now, coming to the frequency spectrum of FM wave, the expression of FM wave is quite complex as it contains infinite number of sidebands. As you can see, this is our carrier signal, the frequency spectrum of carrier. This is the upper sidebands and it is continued to infinity. And this is the lower sidebands, so it is also continued to the infinity. The bandwidth is also infinite. So, by solving this is a very complex situation, and the only way to solve this equation is using the Bessel's function. Using the Bessel's function, as the FM wave consists of an infinite number of sidebands, bandwidth of an FM wave must be wider than the AM signal, as you know that the bandwidth of AM signal is twice of FM. Upper sideband frequency minus the lower sideband frequency. The expression for FM wave is complex since it is sine of sine functions. The only way to solve this equation is by using the Bessel's function. Ideally, the bandwidth of the FM wave is infinite, as we have seen in the diagram. See, the bandwidth is infinite. Okay, because its spectrum consists of infinite number of upper and lower sidebands, but practically it depends on the number of significant sidebands. As the modulation index increases, the number of sidebands have significant amplitudes, which are having significant amplitudes will also increase. So we have divided the basis on this. We have divided our frequency modulation into two parts, that is narrowband FM and wideband FM, NBFM and WBFM, depending on their applications. So NBFM uses low modulation index with a much smaller range of modulation index across all the values of the modulating signal. The range of the modulating frequency lies between 30 Hz to 3 kHz. It is used in police wireless, ambulances, and taxi cabs. Similarly, for WBFM, when better signal quality is required, WBFM is used at the expense of greater spectrum usage. WBFM is used in applications where the modulation index is equal to or larger than 1. The range of modulating frequency in WBFM is 30 kilohertz to 30 hertz to 15 kilohertz. This is the side comparison between both the FMs, NBFM and WBFM. As the modulation index I have already discussed, it is in NBFM it is less than or slightly greater than 1, and in WBFM it is always greater than 1. Maximum deviation is 5 kilohertz in NBFM and 75 kilohertz in WBFM. Maximum deviation means the amount by which frequency can deviate from with reference to the intermediate frequency, that is carrier frequency. So in NBFM it can deviate up to 5 kilohertz, but in WBFM it can deviate up to 75 kilohertz. Range of the modulating frequency is 20 hertz to 3 kilohertz in NBFM and 20 hertz to 15 kilohertz in WBFM. Maximum modulation index is slightly greater than 1 in NBFM and 5 to 2500 in WBFM. Bandwidth is twice of FM, which is same as amplitude modulation, and it is 15 times greater than NBFM. And the applications, as we have discussed, it is in police wireless, ambulance, short range ship to shore communication, taxi cabs, etc. And in WBFM, it is used for entertainment broadcasting, and as we need high quality of transmission in this. So coming to this was all about the frequency modulation, a brief introduction of this. Coming to the phase modulation. For phase modulation, the phase modulation is another type of angle modulation. They are close. Phase modulation is closely related to frequency modulation. It is possible to obtain frequency modulation from phase modulation using indirect method called Armstrong method. We'll discuss Armstrong method in the upcoming 4th lecture only, where we will discuss about FM modulators and demodulators. So what is the procedure of phase modulation? What is the function? The phase modulation is obtained by varying the phase of a carrier in proportion with the amplitude of the modulating signal. As the name suggests, that phase modulation. So only phase changes with respect to the carrier frequency, the carrier amplitude. The amplitude and the frequency remains the constant. So here is the carrier, high sinusoidal wave, and here is the massive signal or the modulating signal. So you can see as the carrier is traveling for positive, it is copying the carrier. For negative side of the modulating signal, it is out of phase. Again, when it is positive, it is in phase with respect to the carrier signal. When it is negative, it is out of phase and it continues. So this is the basic in short introduction of phase modulation. Now coming to the comparisons of FM and PM. The equation for FM is given as VC sine omega CT, MF sine omega MT, where MF is the modulation index of FM signal, and for PM it is VC sine omega CT plus MP sine omega MT. Note the difference that only the modulation index has been changed. Rest of the equation is same. MP is the modulation index of the PM wave. And the frequency deviation is proportional to modulating voltage. Here phase deviation is proportional to the modulating voltage associated with the change in the carrier frequency. There is some phase change and there is some frequency change. Modulation index is proportional to the modulating voltage as well as the modulating frequency, and here it is proportional only to the modulating voltage. It is possible to receive only with respect to the modulating voltage as its amplitude as it changes from positive to negative, the phase changes. But in frequency modulation, as it changes to positive to negative, the frequency changes. Okay. Then it is possible to receive FM from PM, as I have discussed, and we'll discuss in detail in the upcoming lecture. Through Armstrong method, we can obtain FM from PM. How? We will discuss it later. And it is possible to receive PM on a FM receiver. Now, noise immunity is better than AM and PM, and noise immunity is better than AM but worse than FM, sorry. Amplitude of FM wave is constant, and here amplitude of PM is also constant. Signal to noise ratio is better than that of PM, and signal to noise ratio is inferior than that of PM. FM is widely used. PM is used in some mobile systems. In FM, the frequency deviation is proportional to the modulating voltage only. And in PM, the frequency deviation is proportional to both the modulating voltage and the modulating frequency. Coming to the comparison between the FM and AM, these are some of the questions which can be asked in any of the exams, whether it is university exams or whether it is the other competitive exams. It is a very frequent question. Any of the difference can be asked in MCQs, so be prepared with that, students. Coming to the comparison of FM and AM, in FM, amplitude of FM wave is constant, it is independent of the modulation index, but in AM, amplitude of AM will change with the modulating voltage. It's the definition of, first point is the definition of both. The transmitted power remains constant, it is independent of the modulation index of the FM wave, and the transmitted power is dependent on the modulation index. All the transmitted power is useful, carrier power and one side power are useless. In, we are talking about AM, that is DSB FC. FM receivers are immune to noise, AM receivers are not immune to noise. It is possible to decrease the noise further by increasing the deviation. This feature is absent in AM. Okay, students, so the bandwidth is twice of del F plus FM, and here the bandwidth is only FM. Bandwidth is large, hence wide channel is required. As we have already seen, it consists, the frequency spectrum consists of infinite number of sidebands, and in AM the bandwidth is much less as compared to FM. It is only twice of FM, as we have seen in earlier point also. So that's all about FM and PM. Its basic introduction. What are its what does it mean? In the upcoming lecture, we'll deal with the FM modulators and demodulators. So if you have any query regarding this, please let me know. If you are facing any problem regarding whatever I have told you this time in this lecture, please comment on the comment box. I think rest of the things are very clear. It is very basic thing which you might have studied it earlier very thoroughly. So, okay, students, all the best. I hope so. This lecture will help you a lot. Thank you. Say Janand.